We've all stared at that grid of colorful squares on a classroom wall. The periodic table looks like the ultimate static catalog of the universe, orderly, predictable, and frankly a little dry. But those tidy little boxes are hiding a completely different reality. Inside that chart is a metal that melts into a puddle if you hold it in your hand. There's matter that glows in the dark all on its own, and elements so incredibly rare that the entire planet contains only a few grams of them at any given moment. Today, we're counting down the top 10 strangest substances ever discovered. And as we move from number 10 down to number 1, the behavior of these elements gets increasingly difficult to believe. These materials do things that seem to defy the standard rules of chemistry, and yet mastering their bizarre properties is exactly what keeps our modern world running. We start at number 10, gallium. Sitting on a table, it looks like a completely ordinary solid silver metal. But if you pick it up, its structure collapses. Gallium has a melting point of roughly 30 degrees Celsius, which is slightly below your normal body temperature. So the heat from your skin is enough to turn that solid chunk into a shiny liquid puddle right in your palm. Number 9 is francium, an element so scarce that geologists estimate there are less than 30 grams of it scattered throughout the entire crust of the Earth. Even if you could find it, you couldn't keep it. Francium is intensely radioactive and highly unstable, decaying into other elements in a matter of minutes. No human has ever gathered enough of it to see with the naked eye. Right at the bottom of our list, we already have a metal that refuses to stay solid, and an element that barely sticks around long enough to exist at all. Looking at this old-fashioned thermometer, you can see number 8, mercury. It's the only metal that remains a flowing, mirror-like silver liquid at room temperature. Ancient cultures were so captivated by its behavior, they called it quicksilver, convinced it held magical properties. It's also exceptionally heavy. Mercury is so incredibly dense that solid iron and lead will float right on top of it. But that mesmerizing liquid is highly toxic, which is why those vintage thermometers are rarely seen in homes today. Number 7, phosphorus, has a different kind of visual trick. In its white form, its structure causes it to emit an eerie, pale green glow in the dark, completely unassisted, the origin of the word phosphorescence. But that glow comes with a violent temper. White phosphorus is highly reactive and will instantly burst into flames if exposed to the open oxygen in the air, meaning it has to be stored entirely underwater. For centuries, humans thought elements that glowed or flowed like water were supernatural. In reality, they were witnessing the extreme, volatile edges of chemistry. Number 6 is helium. We mostly know it for filling floating balloons and changing the pitch of our voices, but despite being the second most abundant element in the universe, our earthly supply is actually dwindling. When physicists cool helium down to near absolute zero, it becomes a superfluid. At this temperature, the liquid flows with completely zero friction, allowing it to spontaneously climb up and over the walls of an open container, entirely ignoring gravity. Number 5, bismuth, prefers a more structured approach. When melted bismuth cools and crystallizes, it naturally forms sharp right-angled geometric staircases covered in a thin, light-bending oxide layer that shimmers in bright pinks, blues, and golds. Unlike lead or mercury, this heavy metal is remarkably safe for humans. Its soothing chemical properties actually make it the primary active ingredient in many over-the-counter stomach medicines. Whether it's a liquid that crawls up walls or a heavy metal that cures a stomachache, pushing the physical boundaries gives us both mind-bending phenomena and life-saving medicinal tools. Number 4 is cesium, and it is brutally reactive. If you drop a tiny flake of it into a glass of water, the resulting chemical explosion is violent enough to instantly shatter the container. This complex instrument harnesses cesium. By measuring ultra-precise vibrations of a single atom inside this vacuum chamber, physicists define the exact length of a second. Those steady pulses are our infrastructure's heartbeat. This timing allows satellites to coordinate global GPS and synchronize the internet. Number 3 is neon. It's a noble gas, meaning it is chemically aloof, stubbornly refusing to react with other elements as it floats completely invisibly through the air we breathe. But if you trap it in a tube and force high-voltage electricity through it, that invisible gas suddenly emits a brilliant reddish-orange light. This simple reaction is exactly what illuminates these massive casino signs in Las Vegas. From exploding metals that regulate our network servers to invisible gases that light up our cities, our technological landscape relies entirely on domesticating these extreme materials. Moving to number 2, plutonium. This element is so intensely radioactive that a solid block of it will physically feel warm in your hands, continuously generating its own thermal energy. Looking at this photograph of the Voyager spacecraft, you can see how NASA puts that radioactive heat to work. They convert plutonium's natural thermal energy into electricity, providing a reliable power source that keeps probes transmitting data back to Earth after decades of flight. And finally, number 1. Astatine is the rarest naturally occurring element on Earth. Scientists calculate that the entire global crust contains less than a single gram of it right now. You will never see a piece of astatine. Its radioactive decay is so energetic that if you ever manage to gather enough atoms together to form a visible speck, the heat from its own radiation would instantly vaporize it. It exists purely at the physical limits of what matter can endure. At the very edge of the periodic table, an element becomes a cosmic ghost, destroying itself the moment it tries to exist. That familiar classroom grid serves as a map for the most volatile, reality-bending substances in our universe. By decoding the exact mechanics of these elements, from how they crystallize in our stomachs to how they vibrate in a vacuum chamber, we've figured out how to heal ourselves, map the planet, and hurl machines into the dark space between stars. Let me know down in the comments which of these elements surprised you the most. And make sure to subscribe, because next time we're looking at some of the most spectacular, explosive experiments in scientific history. Stay curious.